All right, I'm just going to review with you some helpful tips and tricks on completing your next assignment. So functions are in the world all around us. We know that mathematically we can add, subtract, multiply, and divide them, but they also represent or model different situations, and they help us make predictions. We can also have a composition of functions. So a composition of functions is useful when a change in one function will create a change in another function, which in turn affects a third function. For example, suppose that humans build a housing development on land that was previously used as a cornfield. This change in land usage causes the number of birds in the area to decrease, which causes the number of mosquitoes to increase. So you can model the increase in the number of mosquitoes as a function of the number of birds in the area. So let's go into our situation. Last night, it started raining as Haba was closing up the store where she works. By 3 a.m., the roof of the store developed a small hole and water began to leak onto the sales floor. The water created a circular puddle. At any time t in minutes, the radius of the puddle increases by 0.1 centimeters. The rain continued through the night, but stopped by the time the morning shift arrived at the store at 7 a.m. When the employees arrived at work, the leak and water puddle were discovered. The employees cleaned up the water puddle and placed a tall circular bucket underneath the leak, which was still slowly dripping. The capacity of the bucket can be represented by this f of x function, and by 10 a.m. the amount of water in the bucket can be represented by this g of x function. For number 1, write a function that describes the area of the water puddle on the floor as a function of its radius. So we know the puddle is circular, so think of the area of a circle, and we're representing it as a function of its radius. So we have an a of r. Okay. Write a function that represents the radius of the puddle at time t. Use function notation. So go back into the passage and figure out how much the puddle is increasing by. So what is the rate per minute? And we're going to write that function notation where we've got the radius of the puddle at time t. So we've got the radius of the time t. What is the area of the puddle on the floor when the employees arrive at work at 7 a.m.? Write a composition of functions to help you and round your answer to the nearest whole number. Explain how you found your answer. So we know that the area of the puddle on the floor is a function of the amount of time that has passed since the roof began leaking. So we want to find a of r of t, and then figure out how much time has passed between 3 a.m. and 7 a.m. in minutes. We're going to plug that number in and solve for the area. What function represents how much more water can be added to the bucket before it overflows? Explain how you solved this problem. Here's where we want to go back to our functions f of x and g of x and figure out what they represent. One represents the entire volume of how much water can be held in the bucket, and one represents the amount of water in the bucket at 10 a.m. So we want to figure out how much more water can be added to the bucket before it overflows. Figure out what operation you're going to be doing with these two functions. At around noon, the store roof appears to have stopped leaking. So an employee removes the bucket that was catching the water and does not replace it. Overnight, it begins to rain again, and water starts leaking from the ceiling onto the floor, again creating a circular puddle. The hole in the roof is larger this time, so at each time t in minutes, the radius of the puddle increases by 0.25 centimeters. Write a composition of functions to represent the area of the puddle as a function of time. So we have our composition of a of r of t. But now we have a new r. Plug it in and simplify our function. Look at the function you wrote for question 5. Does this function have an inverse? If so, what is it? Is the inverse the function? Show your work and explain your reasoning. So remember, the inverse is where we flip-flop the x and the y and then resolve for the y. So I'm going to give you an example right here. Again, you're going to take your function that you wrote for question 5. But again, if I take this right here and let's say I'm going to find the inverse, that means I'm just going to replace the x with the y and the y with the x. And now I'm going to resolve for the y. I'm going to get the y by itself, isolate it. So I'm going to multiply by 2 on both sides to cancel that out. So I get 2x equals 3y plus 1. Subtract 1 on both sides. I get 2x minus 1 equals 3y, divide by 3. And finally, my inverse is y equals 2x minus 1 over 3. Now, in order to figure out if it's a function, my suggestion is to take what you got for your inverse, plug it into Desmos, and do any vertical line tests. You want to make sure that that function does not hit the vertical line that you draw at 2 points. We only want our graph to hit any vertical line at 1 point in order for it to be a function. Please note that if you solve and you get a plus minus answer, that when you put this into the Desmos graph, you consider both the positive and the negative options.